For the third exercise, we will simulate what happens to your grinding and classification plant if your feed or hardness change. This is a very common problem on grinding plants. As you dig through the ore body, you might reach a harder or a softer section of the deposit where it's harder or softer to grind this ore in the SAG mill, the crushers, and the ball mill or other breakage equipment. This is a complex problem that receives a lot of attention in this industry. So in exercise 3, we're saying that the throughput has been dropping and it is suspected that the ore has become harder. The bondwork index from the plant slab is usually 14 kWh per ton, but recently it has increased to 16 kWh per ton. Let's simulate the effect of this increase on SAG mill performance. So here we're saying let's click on the SAG mill and then in ore properties evaluate the new type of ore that is coming through the plant. Now when you are in the SAG mill window, it is worth studying the section that we wrote in the ore properties, which explains exactly how we approach ore hardness testing. It is important to note when you look at the ore hardness in the SAG mill that there is no specific number that will always accurately describe the behavior of the ore in the SAG mill. There will always be some fluctuations in performance, but it is important to make predictions within reasonable error margins. Now, in a SAG mill, there are two types of breakage that is predominant. That is impact breakage and abrasion breakage. This is usually in the medium-sized rock, the impact, and the abrasion is usually in the larger rocks inside the mill. Now, in order to represent how these rocks break in terms of impact and abrasion, we have a scale of 0 to 100. 0 being the softest ore and 100 being the hardest ore. So when we have a specific point on the scale, we know how the ore is going to break as a result of this index that we have. So we have established a lot of correlations between existing tests and this index, the impact index or the abrasion index. The one that we find the most useful is the correlation between impact and bondwork index, and the correlation between abrasion and bondwork index. It is important to note that you cannot use the bondwork index by itself as a direct input into SAG mill modeling, but you can use it to find a correlation to impact and abrasion. However, if you do that, you must do simulations within a certain range around this number to account for possible error in measurement. So if we say, for example, 16 and we convert it, we can see that we have now calculated impact index and an abrasion index based on our bondwork index measurement. So here we warn you that if you are using this method, we recommend that you simulate plus minus 10 points around this index. So do a few simulations where you simulate around these numbers. And it is a good idea to do this and then to find a scenario that works for the full range of index numbers that you choose. If we do a simulation around this scenario, you will see that we have some problems in the sag mill, and our problem here is that we have a low filling for this specific case. So again, with this low filling, we will have some issues with our throughput, and we can probably change the mill speed as a way to deal with this specific issue. So we recommend when you do this demo exercise to play around with the feed ore hardness here and see the effect it has on the performance of the plant.